Hello dear viewers, you are most welcome to Algebra 2 Mathematics channel, and thanks for watching. Tonight I brought you lesson 3 video of our topic equations of straight lines. And please, if you are not this channel, kindly subscribe, turn on the notification button so that you are notified whenever I upload any video, like and share. Tonight we are proceeding with our topic and we are to cover the following as you can see on the screen. In this video, we are going to cover the following. Number 1, we are going to understand how we can get the length or magnitude of a straight line. Then number 2, we shall determine the midpoint of a straight line. Number 3, we shall understand about parallel and perpendicular lines. Number 4, we shall draw or understand how to draw a straight line passing through any given 2 points. Then we shall have talk about obtaining equation of a line given the gradient and the y-intercept. Number 6, we shall talk about how to obtain the equation of a line given the gradient and a point on the line. Then number 7, we are talk about obtaining the equation of a line given 2 points on it. Then number 8, we shall talk of obtaining the equation of a line which is parallel to a given line and passing through a given point. Number 9, we shall also talk about or understand how to obtain equation of a line which is perpendicular to a given line and passes through given points. Number 10, we shall understand how we determine the point of intersection of lines. So now you are welcome. And if you are not this channel, please kindly subscribe to the channel, support the channel, and please follow. Where you don't understand, you ask a question, you can drop a comment in the comment section for whichever question. Thanks. Let us now dive in. Start by understanding how we can get length or magnitude of a straight line. If now we consider the line AB, as you can see, we have here A and the B is here in the Cartesian plane with the coordinates x1 and y1, and then B as x2, y2. So this is what we are saying, that the coordinate A is having the x1, then y1, whereas the coordinate B is having x2, y2. As you can see here in the Cartesian plane, then this is our line. As you can see, it is our line for which we are to determine its length. And the length we are determining is from point A to point B, just here. That is the distance we are to determine, or the length. And which formula do we use? That is our question. Which formula can we use to determine the distance of this line, which is from point A to point B? So we are determining the distance AB. I can say this is AB, the distance. Gonna be the magnitude here of the line AB. So this is derived from the Pythagoras theorem, whereby as we consider the triangle there, in case this point we call it maybe point D, if we extract out that triangle, it's gonna be of this form. We are going to have this as our triangle, putting in mind that this is a right angled triangle. So here we have point D, we have the A, and then the B this side. So we are saying that this is the magnitude of line AB. We have to get its magnitude, and we know very well that point B is at x2, y2, then point A is at x1, y1, implying that this is x2 and then this is x1, whereas we have the y1, and then up here we have the y2. So now by Pythagoras theorem, it means that our AB squared equals to the AD squared plus the DB squared. So from here we are going to substitute in, but we have the AD being equal to, as you follow here in the diagram, AD is the x2 minus x1, and as well the DB is the same as having y2 minus y1. So as we see our substituting here, we are going to have the AB squared being equal to the AD, which is the x2 minus x1, but the whole of it is squared since we have AD squared, plus our DB, which is the y2 minus y1, the whole of it is squared. As we simplify, it implies that So now from here, remember we want to get AB. So we have the AB but squared being equal to the x2 minus x1, the whole of it squared, plus the y2 minus 1, the whole of it squared. Remember, I want to get AB. What we do, we are going to take the square root on both sides of the equal signs. Say that on the left hand side we have the AB being equal to the square root of the x2 minus x1 by the whole of it squared, plus the y2 minus y1 by the whole of it squared. And in here, if this is positive only, it means that we have got the magnitude of the line AB, implying that this is our formula that we do use when you are to get the magnitude or the length of a line passing through any given 2 points. We can now have examples. Let us have example. Find the length of the straight line joining each of the following pair of points. We have part A, B at 1, 3, point D at 4, 7. So they want us to determine the length of the line passing through any of these 2 pairs of coordinates. So we are going to have our response here written and explained very well. Remember, we are going to get the distance or the magnitude of the line, the BD, which is from the formula. We are going to have the square root of x2 minus x1 by the whole of it squared, plus the y2 minus y1, the whole of it squared. From this point, we can now have B, which is at 1, 3, and then the D, which is at 4, 7. We can let the x1 to be a 1, and then the y1 to be the 3, whereas the x2 is now automatically becoming the 4, and then the y2 becoming a 7. So as we substitute in, we are going to get our magnitude of the line BD being equal to the square root of the x squared. The x2 is the 4 minus the x1, which is 1, by the whole of it squared, plus the y2, which is a 7, minus the y1, which is 3, by the whole of it squared. As we simplify, we are having the magnitude of BD giving us the square root of 4 minus 1, we are getting 3, but squared, plus the 7 minus 3 giving us a 4, but squared. As we simplify, we are going to have the length of the line BD being equal to the square root of 3 squared is a 9, plus the 4 squared is 16. So we are getting our magnitude of the line BD being equal to the square root of 9 plus 16, giving us the 25. Then as we simplify and get the square root of 25, we are getting our length of the line BD being equal to the 5 units. So this becomes our magnitude or length of this line, which is at coordinates 1, 3, and 4, 7. We can try out still B, part B. So for part B, remember we are having our T. Point T is at negative 7, negative 1, and the point Q, which is at negative 1, negative 4. If you can see, let me stress it and you observe it is there. You have T negative 7, negative 1, and Q negative 1, negative 4. So from here, we do the same. We are getting the magnitude of the line TQ, which is from the formula. We are going to have the square root of the x2 minus x1 but squared, plus y2 minus y1 squared. So we can now let our x1 to be negative 7, then automatically y1 becomes negative 1, also x2 to be the negative 1, and then y2 to become negative 4. So it implies that our magnitude, rather the length of line TQ, equals to the square root of the x2, which is the negative 1, minus the x1, which is negative 7, by the whole of it squared, plus y2, which is negative 4, minus the y1, which is negative 1, the whole of it squared. As we simplify this, we are getting the length of line TQ being equal to the square root of negative 1 minus negative 7. We are going to have negative 1 plus 7, which gives us a 6 but squared plus the negative 4 minus negative 1. So we are remaining with negative 3 but the whole of it squared. So the length of line TQ equals to the square root of 6 squared, we are getting 36, plus negative 3 squared, we are getting 9. As we simplify, we are going to have the length of line TQ being equal to the square root of 45. So this is the same now as the square root of 45 is the 6.708203932.5 units. Or somebody can even leave it at this stage and say that the length of TQ, line TQ, equals to the square root of 45, and you put the ints. It should be a positive answer because the length of any line or length has magnitude only, meaning it is a scalar quantity. So we are left with part C. You will try out part C and determine the length of the line passing through these points N and P. Let us now proceed to the next subheading, which is none other than the midpoint of a straight line. So now, how do we determine the midpoint of a straight line? And what is the midpoint of a straight line? Here, when we talk about midpoint, we mean midway, in the middle of a given line. And what is that coordinate there? If you consider a line, for example, if you have a line, maybe a line AB, as we can see here, what is the midpoint of this line? What is the middle coordinates of this line? In case we divide it equally into two parts, what is the coordinate of this point? So that one is now the midpoint, which we are calling M. And we are saying that if A and B have coordinates, the x1, y1, and B having x2, y2 respectively, the coordinates of the midpoint M, so we are calling it the midpoint M, of the line joining AB is given by this formula, as you can see here. So that coordinate of M is equal to the x2 plus x1 divided by 2, then y2 plus 1 divided by 2. We can have examples here. So that find the coordinates of the midpoint of a straight line joining each of the following pairs of points. We can have our response here. For part A, we are having the coordinates as negative 2, 1 and 6, 5. So in here we can let maybe x1 to be equal to the negative 2. Automatically y1 becomes 1. Then x2 being equal to the 6. Then y2 equals to the 5. From the formula, the midpoint, if we say that the midpoint is M, equals to the x2 plus x1 divided by 2, then y2 plus y1, all of it divided by 2. Let us now substitute in to get the midpoint, which is M. So M equals to, for this case, our x2 is 6, so we have 6 plus, so this is x1 plus x1, which is negative 2, the whole of it divided by 2, comma. Then we have y2, which is 5, plus the y1, which is 1, the whole of it divided by 2. So as we simplify, we are getting our midpoint M being equal to 6 plus negative 2, we are getting 4, but divided by 2. Then 5 plus 1, we are getting 6, divided by 2. As we simplify, we are getting our midpoint M to be the 2, comma, then a 3. Since 4 divided by 2 is 2, then 6 divided by 2 is 3. Therefore, the midpoint of the line passing through negative 2, 1, and 6, 5 is 2, 3. So now this becomes our correct answer for this part A. We can now go to part B of our question. Part B, remember we have the coordinates as negative 2, 6, and negative 8, negative 5. So we want to determine the midpoint of the line passing through these points. We can now let maybe x1 to be equal to negative 2, then y1 automatically becomes 6. Also the x2 is now equal to the negative 8, then y2 equals to the negative 5. From the formula, we are determining the midpoint, which is equal to the x1 plus x2 divided by 2, then y1 plus y2 divided by 2. Hey, somebody may say that I've interchanged. It is okay. So we are going to have our m being equal to, as we substitute in, our x1 is negative 2 plus our x2, which is negative 8, by the whole of it divided by 2. Then our y1 is a 6 plus our y2, which is negative 5, the whole of it divided by 2. As we simplify this, we are getting our midpoint m to be equal to negative 2 plus negative 8, we are getting negative 10, but divided by 2. Then 6 plus negative 5, we are getting negative 1 divided by 2. So as we simplify, our midpoint m is coming to be negative 10 divided by 2, we are getting negative 5, and then a negative 1 out of a 2, which is the negative 0.5. So therefore, the midpoint of the line passing through points negative 2, 6 and negative 8, negative 5 is negative 5, negative a half. So this becomes our correct answer for that case. You will try out part C and determine the midpoint of the line passing through these points. Allow me jump over to another subheading and talk about the parallel and perpendicular lines. So what are parallel lines? For part A, we begin with parallel lines. Say that lines are said to be parallel if they do not cross the path of one another. In other words, they will never meet. Parallel lines are lines that never meet at any point, even when extended indefinitely. So we are saying that parallel lines have the same gradient. So it is important to know that parallel lines have the same gradient or slope. You have to take note of that. If now we consider the diagram here as the Cartesian plane, we have these three lines, whereby we have line 1, line 2, and then line 3. We have our x-axis, as you can see here, and then the y-axis. So these three lines, we can see that they are parallel. And since they are parallel, it implies that they have the same gradient. You have to take a note of this statement here. All parallel lines have the same gradient or slope. And that is how we can know that such lines are parallel. We just need to calculate their gradient or slope, and if we compare and see that they have the same gradient, then we shall say that those lines or the lines passing through the given points are parallel. Let us have examples. They are saying that use the points A, B, C, and D to show that line AB is parallel to line CD. So in here, as earlier on in lesson 2, we could determine the gradient of a line passing through any two given points. So in here simply, we are going to have our response. Let us first get the gradient of the line AB. Remember from the formula, gradient M equals to the change in Y divided by the change in X. What does it mean? It means that our M is going to be equal to the y2 minus y1 divided by the x2 minus x1. Concerning the points, the A, which is at 2, 4, and then the point B, which is at 8, 7, we can let this to be the x1, this one to be the y1, and then the 8 to be the x2, and then 7 to be the y2. From this, as we proceed, we are going to get our M of line AB being equal to the y2, which is the 7, minus the y1, which is 4, divided by the x2, which is 8, minus the x1, which is 2. As we simplify, we are getting our gradient of the line AB being equal to 7 minus 4, we are getting a 3, divided by 8 minus 2, giving us 6. As we simplify by reducing by factor of 2, of 3 we are going to have 1 out of 2. So therefore the gradient of line AB is just simply a half. Let us now go ahead and get the gradient of line CD. For line CD, we have C at 5, negative 1, then D at 19, 5. So we can let it be x1 and then this to be y1, this to be x2, and this y2. So from here, our m gradient from the y2 minus y1 divided by the x2 minus x1, it means that our gradient m is simply gonna be the y2, which is 5, minus the y1, which is -1, divided by the x2, which is 19, take away the x1, which is 5. As we simplify this, we are getting our gradient m being equal to 6 divided by 19 minus 5, we are getting 14. So as we reduce, we are getting by 2, we are getting 7, then by 2 we are getting 3. So we have 3 divided by 7, implying that the gradient of line CD equals to the 3 divided by 7. Now, as we compare these two gradients, we can call this might be M1, this to be M1, and then this automatically becoming the M2. So the M2 is equal to a half. So when we compare these two, or we look at them, these two gradients are not the same, and therefore the lines passing through these points are not parallel. Therefore, the lines passing through these points are not parallel because their gradients are not the same. So the gradients are not the same. Let us now move to perpendicular lines. So now, what are perpendicular lines? A line is said to be perpendicular to another line if they meet at a right angle to one another. So if they meet at 90 degrees, then we shall say that those two lines are perpendicular to one another or to each other. And it's important to note that the product of the gradients of a pair of perpendicular lines equals to the -1. So it is very important to note that, i.e., if we consider two perpendicular lines, L1 and L2, and their gradients as M1, M2 respectively, this is what we are meaning, that if we get the product of their gradients, then the answer we get should be a -1, as you can see in this table here. Let us have an example. The example is here. Given 3 points, A, C, and D, prove that the lines AC is perpendicular to line CD. So in here, simply first get their gradients. So for line AC, let us call its gradient M1. So it means that our M1 is gonna be equal to the Y2 minus Y1 divided by the X2 minus X1. Since it is passing through the point A at 2, 4, and then the point C at 5, -7. Let us call this to be X1, this to be Y1, then this is X2, then Y2. It means that our M1 is gonna be equal to, as we substitute in, Y2 is -7 minus the Y1, which is 4, divided by the X2, which is 5, minus X1, which is 2. As we simplify, we are getting our M1 being equal to the -11 divided by 5 minus 2 is a 3. So this is our M1. Let us also get the M2 for the line CD. For the line CD, we are calling it M2, which is going to be equal to the Y2 minus Y1 divided by the X2 minus X1. So since it is passing through point C at 5, -7, and point D at 19, 5, we can call this to be X1, this to be Y1, then this is X2, Y2. As we substitute, we are getting our M2, which is standing for gradient, equals to the Y2 is the 5 minus the Y1, which is -7, divided by X2 is 19 minus the X1, which is 5. So as we simplify, we are getting our M2 being equal to 12 divided by 14. As we reduce, we are getting our M2 being equal to the 6 divided by 7. So we need to test whether these two lines or the lines passing through these points are perpendicular. We are now going to get a multiplication of M1 multiplied by M2, which is simply equal to, so we are getting our M1, which is -11 divided by 2, multiplied by our M2, which is 6 divided by 7. So this is equal to this by 2, 1 by 2, 3. So we are getting -33 divided by 7. Since for perpendicular lines, our M1 multiplied by M2 should be equal to the -1, then it implies that these two lines are not perpendicular. since this is not equal to the negative 1. Therefore, the lines are not perpendicular. So they are not perpendicular to one another. We can now go to the next subheading, which is none other than drawing a straight line. So in here, we are going to draw a straight line passing through any two given points. And we are saying that when drawing a straight line, we simply need 2 points lying on the line. For example, we've been given here that draw a line that passes through the given points. I can try to draw here the Cartesian plane. If this is x-axis, and then here we have the y-axis, and this is I'm putting 1, this is a 2, 3, 4, and then 5. This side we have the negative 1, the negative 2, the negative 3, the negative 1, negative 2, negative 3. Then we have 1, the 2, 3, like that. So we have it at 0. For my number 1, we have 0, 2. 0, 2 is at this point here. Then 2, 4, 2, 4. So the 4 could be somewhere here. And then we have to join using a straight line. So that one could be the line we have to get. It is done likewise for the other parts. It is done the same way for Roman numeral 2 and then Roman numeral 3. Note that this should be drawn in the Cartesian plane or in the grid of lines, probably on the graph paper. Take a note that you have to draw it on a graph paper. Note that it should be drawn in a graph paper. Alright, thanks for watching. See you again next time.